Good morning, children. Welcome back to Sairam Educational Channel. Today we will be seeing about class 10 mathematics, some questions from the lesson polynomials. This is the question given. If alpha and beta are the zeros of a quadratic polynomial, the polynomial f of x equal to x square minus x minus 4, then find the value of 1 by alpha plus 1 by beta minus alpha beta. So to do that, we need to know the relation between sum of zeros and the product of zeros. First you take the polynomial, that is x square minus x minus 4, and compare this with the general formula of polynomial ax square plus bx plus c, where a equals to, as per this given polynomial, a equals to 1, b equals to minus 1, that is the coefficient of x term, minus 1, and c equals to constant, that is minus 4. Now, as you know that the sum of polynomials, if polynomials are alpha and beta, the sum of the polynomials, that is alpha plus beta, equals to minus b upon a, so that equal to minus of minus 1 by 1, that equals to 1. Then alpha beta is equivalent to c by a, c upon a, that c equal to minus 4 over 1, a equal to 1, that equals to minus 4. Now you have two values, one is alpha beta and alpha plus beta. So what the problem is that they asked to find out the value of 1 by alpha plus 1 by beta. Now write down this 1 by alpha plus 1 by beta minus alpha beta. So now if you take LCM of these two, these will be alpha into beta. So this becomes beta plus alpha by alpha beta. So that implies this becomes beta plus alpha by alpha into beta, because LCM is alpha into beta. So alpha beta times beta 1 is beta plus beta alpha times alpha 1 is alpha. So minus alpha beta, that goes to, now you know that alpha plus beta value, that equal to 1, substitute here, and alpha beta value, that equal to minus 4, substitute over here, minus alpha beta, the product is minus 4, minus of minus 4. So I substituted alpha plus beta value and alpha beta value and alpha beta value, the same we have done. So that becomes 1 by minus 4 minus 1 by 4 plus 4, that goes to 4 minus 1 by 4, 4 plus 4 minus 1 by 4, that equal to 4 is the LCM, so 16 minus 1 by 4, that equal to 15 by 4. So the value of alpha, 1 by alpha plus 1 by beta minus alpha beta equals to 15 by 4. The next question is, if alpha beta are the zeros of a quadratic polynomial, the polynomial is given f of x equal to x square minus k plus 6 times of x plus 2 into 2k minus 1. Then the value of k, if this is the condition, alpha plus beta equal to 1 by 2 alpha beta. So for any such problems, first we should take out the polynomial given. You write down the polynomial x square minus k plus 6 times of x plus 2 into 2k minus 1, and take out the ABCs when comparing with the standard polynomial equation, that is ax square plus bx plus c. So given a equals to coefficient of x square, that equal to 1, and b equals to coefficient of x, that is minus of k plus 6. People generally do mistakes at this sign only. They miss the sign, then the problem will be wrong. And then c will be the last constant term, that is equal to 2 into 2k minus 1. So now you know that if alpha beta are the zeros, then the sum of the zeros, alpha plus beta, equals to minus b by a. This is general form. So you substitute b value, that is minus of minus k plus 6 by a. A is how much? 1. This becomes minus becomes plus, that becomes k plus 6. So alpha plus beta equal to k plus 6. Then the product of these zeros, that is alpha beta equal to c by c over a. C is how much? 2 into 2k minus 1, whatever we have here, and a is equal to 1. That equal to 2 into 2k minus 1. 2 into 2k minus 1. So now these are the two things we can get from the given equation. Now you see what the question is. So now they ask you to find the value of k. If alpha plus beta equal to 1 by 2 alpha beta, you take that same one, alpha plus beta equals to 1 over 2 alpha beta, and substitute, you know, alpha plus beta equal to this value, and alpha beta is this. Those two you substitute here. Then alpha plus beta, in terms of alpha plus beta, just I am substituting that value, that equal to k plus 6 equals to 1 by 2 alpha beta is 2 into 2k minus 1. So 2 can be cancelled out. So k plus 6 equals to 2k minus 1. That implies 2k equals to, 2k can be kept here, that is one side, and minus can be moved this side. So minus 1 becomes plus 1. So this becomes k plus 7. 6 plus 1, 7. K plus 7. So that k also can be moved one side. Then 2k minus k equals to 7. That implies 2k minus k is equal to k. K equals to 7. So this is the value of k. So once again, let us see, if alpha beta are the zeros of a quadratic polynomial, whenever they give a quadratic polynomial, take out the quadratic polynomial and identify its coefficients. X square coefficient is a, b x coefficient is b, and constant is c. After that, you know, there is a alpha plus beta sum becomes minus b by a, and product of alpha beta becomes c by a, and get those values, and those two values substitute over here, then solve for it for k equal to 7. So this is the way we need to do the problem solving.